Today we're going to be studying mathematics
and emerges from the second mirror.
These words sound
Be your teacher for today.
Hi, you're welcome to class today. All right. Remember, at the end of this module, you'll be writing an examination, and if you completely go through the 3 modules prepared for this mathematics online home lesson, you will be sure to have an excellent grade in whatsoever professional exam you will be taking at this level. Just ensure you follow through. If you have any challenge, go through again, and if you still do have a challenge, please get across to us through the WhatsApp number displayed on your screen. I'll be glad to know that you were able to get an excellent grade in any examination at this level. Okay, today we'll be talking about plane figures. Plane figures, 2-dimensional shapes, angles, types of angles, and measuring angles. All right, now 2-dimensional shapes are flat shapes. They seem not to have a depth. So they seem to have just 2 dimensions, as the name implies, 2-dimensional shapes. Let's talk about 2-dimensional shapes. We'll be looking at different 2-dimensional shapes, and we want to look at their properties. Okay, let's talk about the square. Okay, this is a square. This is a square. Okay, now what are the properties of the square? Properties of the square. First, a square has all its 4 sides equal in length. All its 4 sides equal in length. That means this length is equal to this length, equal to this length, and equal to this length. So all the 4 sides are equal in length. And then each of this angle, this square has 4 angles, and each of them is a right angle because there are 4 square corners here. Okay, 4 square corners, 1, 2, 3, and 4. Now, another property of a square is that a square has 4 lines of symmetry. 4 lines of symmetry. A line of symmetry is a line that could divide a shape into 2 equal parts. Let's try looking at the line of symmetry in a square. If this is a square, okay, we could have a line of symmetry this way. 1 shares the square into 2 equal parts. You could also divide this way. 2, the second line of symmetry, you could divide this way. 3, the third line of symmetry, you could also divide this way. 4, the fourth line of symmetry. You would observe that all the lines of symmetry passes through this point. So we've seen the properties of a square. The 4 sides are equal in length, and then the angles, the 4 angles are right angles. Then we have 4 lines of symmetry, and the diagonals bisect one another. Okay, let's talk about a rectangle. A rectangle. Okay, this is a rectangle. A rectangle, you could also draw a rectangle this way. Okay, for a rectangle, it has two opposite sides equal in length. Two opposite sides equal in length. That means this side will be equal to this side. These are equal, then this equal to this. So opposite sides are equal. And then the opposite sides too are parallel lines. Parallel lines are lines that stay same distance apart. We'll still come to that in another topic. So if you continue to extend this line, it would continue to stay same distance apart. If you keep extending these lines, they stay same distance apart. Now the line of symmetry. A rectangle has just two lines of symmetry, unlike a square that had four lines of symmetry. So for a triangle, we could divide a triangle this way into two equal parts, or this way. So there are two lines of symmetry in a rectangle. It also has four right angles, four square corners. So this is 1, 2, 3, and 4. The diagonals of a rectangle too bisect one another. Diagonals this way. So this diagonal not line of symmetry. So those are the diagonal. Now let's talk about a triangle. A triangle. From a rectangle, we could easily get a triangle. Let's draw the picture of a triangle. This is a triangle. Now, a triangle has three lines. The properties of a triangle would depend on the type of triangle. There are different types of triangle. We could have a right-angled triangle. A right-angled triangle has one of its angle as 90 degrees. So this is a right-angled triangle. Now, we could also have an isosceles triangle. Isosceles triangle. This is a right-angled triangle. Right-angled triangle. This is an isosceles triangle. An isosceles triangle has two sides equal. Now it has a line of symmetry, one line of symmetry. Okay, and now this line of symmetry makes a right angle at one of the end. So this is a right angle. All right. Okay, this isosceles triangle line of symmetry also bisects at one of the tips here, bisects the angle into two equal parts. So this angle will be equal to this angle. So we've seen the properties of an isosceles triangle. Two lines equal, two sides equal. Now we also have a scalene triangle. If you look at this angle, okay, let's take a better shape. Okay, look at this shape. None of those sides are equal. A scalene triangle has no part, no line equal. No part of it is equal. Now we have an equilateral triangle. Equilateral triangle. All the lines here are equal. So all are equal, and because all are equal, we have three lines of symmetry. Three lines of symmetry. 1, 2, and 3. Each line of symmetry bisects the angles. So there is a bisect here, one here, and one down here. So those are the properties of an equilateral triangle. So we have the angles here would also be equal. All right. Now let's talk about angles, types of angles. Types of angles. Types of angle. Like we said, the angle at a square corner is a right angle. So this is a right angle. The angle here is 90 degrees. 90 degrees. So this is a right angle. Now we have an acute angle. Acute angle. An acute angle is less than 90 degrees. That means an acute angle is not up to 90 degrees. Look at this. Anything below 90, so less than 90 degrees. We also have an obtuse angle. Obtuse angle. An obtuse angle is greater than 90 degrees but less than 180 degrees. Okay? If you produce this line here, this will be 90 degrees. So you can see this is more than 90 degrees, but it is not up to 180 degrees. And then we have a reflex angle. A reflex angle is greater than 180 degrees. It's greater than 180 degrees, but it's less than 360 degrees. You know, the angle on a straight line, angle on a straight line, the angle on a straight line will be 180 degrees. If we have this is 90 and this is 90. So the angle on a straight line is 180 degrees. So for a reflex angle, it's greater than 180 degrees but less than 360 degrees. Now let's take some examples. Okay. What type of angle will these angles be? This is 80 degrees. An angle that is 80 degrees is less than 90 degrees. So it is less than a right angle. So what type would it be? It would be an acute angle. So we write here acute angle. Okay? 109 degrees. 109 degrees is greater than a right angle, greater than 90 degrees, but is less than 180 degrees. So what type of angle will this be? Obtuse angle. Obtuse angle. Now the third one is 90 degree. 90 degree angle at a square corner is a right angle. Right angle. Then the last one, we have 240 degrees. 240 degrees. This angle is not up to 360 degrees, but it's more than 180 degrees, so it will be a reflex angle. So we write reflex angle. I hope you got that. All right, let's look at how to measure angles. How do we measure angles? When you have a given shape, you want to find out the angle. All right, we measure angles with a protractor. On a mathematical set, you have something like this, like a semicircle. It's called a protractor. Now we can use this to measure angles. I've made a bigger form of it for you to see. Okay, I have a given angle and I do not know, although we could estimate angles, but we could also take actual readings of angles. Take for instance, I have an angle on the board and I want to measure. Okay, I want to measure angle B. Although this protractor looks small for this, let's see what we can do with it. Okay, there should be a straight line here which shows the 90 degrees, this line. So let's make out this line from this point. Okay, now you place your protractor, you see the 90 degrees line directly on this, on the straight line. Make sure it's aligned. Now this horizontal line on the protractor should also be aligned on this line. Okay, so from here I want to look at this angle B. Okay, this is 0, 10, 20, 30, 40, 41, 42, 43, 44. So I have measured 44 degrees. 44 degrees. So angle B is 44 degrees. Angle B is 44 degrees. What if I have something like this? Okay, my straight line, and I have this angle this way. Okay, now we need this angle. Let's call this angle X. We want to find the whole of this. What do I do? Using our protractor again, we'll place it, the vertical line of 19 on this vertical line, and this horizontal line aligned on the horizontal line of the protractor. It will be very easy on your exercise book. Okay, so this is 90 degrees on my vertical line, and I've aligned this on the horizontal line. Okay, now I want to measure this 90 degrees, 90, okay, 100, 110, 120, 130, okay, 130, 131, 132. Okay, so this angle X is 132 degrees. Can you see? It's very easy and it will be fun doing it on your exercise book. All right, what about on a clock? On a clock, remember your protractor is like a semicircle. Your protractor is like a semicircle. All right, on one side of it you have 0 to 180. On another side you have 180 downward. One is going 0 to 90, then to 180, the other side going this way, clockwise and anti-clockwise, so you could measure in either direction. Now assume I want to move some hours on the clock. How do I count how many degrees I've been able to move? Okay, on this clock, it's almost 2. Okay. Now, this is a midpoint. This is a midpoint. And angle at a point is 360 degrees. I have 0 to 12. So if I divide 360 by 360 divided by 4, I'll have 90 degrees. So this is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Okay, that means if this is point 12, point 3, between 12 and 3, I have 90 degrees. Between 12 and 3, I have 90. And I need to share 90 between them. So 90 divided by 3, 90 divided by 3 is 30. So I have 30 degrees. That means each hour move on the clock is 30 degrees. So from point 12 to point 1 is 30 degrees. From point 1 to point 2, 30 degrees. From point 2 to point 3, 30 degrees. So if I'm to move from 3 to 5, from point 3 to point 5, how many degrees would I have moved? So from 3 to 4, that's 1, that's 30 degrees. 30 times 1 is 30 degrees. And from 4 to 5, another 30 degrees. 30 plus 30, 60 degrees. That means I should have moved 60 degrees. Okay, I hope that is clear. So on each hour move on the clock, you move 30 degrees. So let's also take some activities to solve on our own. All right, using a protractor, measure and draw an angle of 85 degrees. Number 2, enumerate 3 properties of an equilateral triangle. And number 3, how many degrees does the hour hand on the clock move through from 5 to 8? By the time you have gone through this topic, you'll find this very easy. I'm so glad you are part of this class. It will be interesting to still have you in the next lesson. Thank you. Bye-bye.